All right, Physics 30s, Mr. T here. Looking on page 118, we're going through the Bohr model. Explains why the meat was in such a low energy state, because it was ground. Okay, it's in the ground state. All right, terrible humor. Question number one. We're looking at an electron in the Bohr's H hydrogen model, has a radius of 3.3856 nanometers. What is the orbital speed? We equate the electric force and the centripetal force. And so from Coulomb's law, kq squared over r squared is equal to mv squared over r. And what we'll do is we'll solve it for v. That's what we're looking for. So let's cancel off a power of r. R is non-zero. Well, we'll just multiply straight across by r. And then we'll divide both sides by m. And so v is going to be kq squared over r m. And we need to square root. So 8.99 E9 times 1.6 E negative 19, the charge an electron and a proton, over the radius that's given, 3.3856 E negative 9 times the mass, 9.11 E negative 31. That's the mass of the electron. Don't forget to square root there, okay? And the calculation. And square root. Looking at 2.73 times 10 to the 5. All right, take a look at question number 2. Just getting warmed up here. The orbital speed of the electron in Bohr's hydrogen model is 2.185 times 10 to the 5 meters per second. And what is its orbital radius? Same sort of solution, but we'll just solve this for r. So solving for r, we're going to have r is same basic equation, okay? We have kq squared over mv squared. And the speed 2.185 E5. Don't forget to square that. And what do we have here? A calculation. Oops, times 2.185 exponent 5 squared. All right, 5.2915 E negative 9. Now, if we wanted this one in nanometers, we could say it would be 5.2915 nanometers. Okay, let's do another problem or two. All right, let's take a look at question number 5, okay? An electron in the Bohr hydrogen model drops from n equals 6 and emits a photon with a wavelength 2.618 micrometers. To which lower level did it fall? Well, 2.618 micrometers, that seems to be more in the infrared part of the spectrum. So we're presuming maybe it fell to level 3 or level 4. Okay, so let's go ahead and just do the calculation for the energy of the photon. Energy of the photon is hc over lambda. So for Planck's constant, what I'll do is I'll use the 4.14 e negative 15 eV seconds. Okay, 3e8 for the speed. And over here on the wavelength, we've got 2.618 e negative 6 meters. If I put in all the units, you'll see how the units kind of work out. The seconds will cancel off, the meters will cancel off, and I'll end up with an energy in electron volts rather than in joules. Okay? And the calculation. Okay, so I have 0.474408. Okay, so now we can go ahead and use our change in energy. Our energy of the photon is really the change in energy of the atom is what I was going to say there. So we can think about the change in energy of the atom is the energy of the photon, which is the energy of the upper level, subtract the energy of the lower level for the electron. Okay, I know they use an L and a U in the workbook there, but in the previous page. When I'm just going to go with this, it's pretty straightforward, no big deal. It's not really a new formula or anything like that. So it asks here, to which lower level did it fall? Well, I want to know this lower level. And so I'm going to solve this for the lower level. And so I want to go ahead and rearrange. So I'm going to move this over here. That there we have E upper minus E photon. So the upper energy level here was 6, which is negative 0.378 eV. Subtract away the energy of the photon, which is 0.474408. So, whoa, okay, sorry. Let's get the calculation done here. So I have negative 0.378. Take away that. Okay, negative 0.852. Okay, well, 85 is pretty close. Which corresponds to about a value of n equals 4. Okay. All right, I'm going to take a break. I'll do maybe one more after this.